Dorissa, I think I might have skipped over you for your mic check. Do you want to do a quick mic check?
Does it work?
Yeah, you sound great. Thank you. Sorry if I skipped over you.
No worries. I wasn't here for a while because I did my lunch. Thank you.
One minute. Emily, I don't have to do anything else in terms of letting people in. It was just switching people over, but otherwise attendees should be able to just get in and are in the room, no problem.
Yep. So hi, everybody. Thank you guys for joining. We're just going to wait a few minutes before getting started to allow anyone else who might be joining us a little late to sign on.
Nick, that is amazing. I'm gonna take some screenshots as we because there's some pretty amazing questions.
I don't have a paddle. Just debating on using a Swiffer, a little stick, and just pretending.
It could work. You could be like a Venice gondolier.
Okay, so I'm going to get started. Welcome everybody, and thank you guys again so much for joining us. Just a few technical notes I'm going to review before we get started. So everyone is auto muted upon entering the event, and your video is off as well. And you're not able to change these settings, so please direct any questions, comments, or technical issues to the chat box. And these technical issues we'll address right away, and then questions and comments will be answered towards the end of the presentation. So let's get started. Slide change, please. Thank you. So my name is Emily, and I'm the Assistant Manager for the Great Canadian Shoreline Cleanup. I've been with the program for about 9 months now, and I'm located in Toronto, Ontario. The trash team is hosting a contest. I've got mine on, and I hope you have yours as well. As many of you might already know, as a result of COVID-19, we're currently advising that all cleanups be canceled or postponed until it becomes clear that we can all participate safely. So since we aren't able to get out on our shorelines, the Shoreline Cleanup team has put together a webinar series where we host a new webinar each week on various topics to engage audiences on issues related to freshwater and ocean health. And with that being said, today we will be celebrating the first annual Ontario Day Against Litter with the University of Toronto's trash team, who will be diving into some of the upstream solutions they've been working on to reduce plastic pollution. Next slide, please. So before we get into that, a little bit about our program. So the Great Canadian Shoreline Cleanup began in 1994 with a group of very motivated Vancouver Aquarium employees and volunteers who decided to clean up a beach in Stanley Park, which for those of you who don't know is where the Vancouver Aquarium is located. And in 2010, we became a partnership of OceanWise and WWF Canada. And today we are the largest direct action conservation program in Canada, and each day we continue to work to inspire Canadians across the country to keep all types of shorelines free of litter. So since our establishment in 1994, our volunteers have organized over 27,000 cleanups and collected over 2 million kilograms of litter across 44,000 kilometers of shoreline. And when it becomes safe to clean up again, we're anticipating our 1 millionth citizen scientist, which is pretty great. So now I'm going to pass it on to Lisa, who will tell you a little bit more about the trash team and why we are here today.
Hello, everyone. My name is Lisa Erdl, and I'm one of the founding members of the University of Toronto trash team. I'm also a PhD candidate in the Rochman Lab. And today I'll start with a brief introduction into the University of Toronto trash team. I'll tell you a little bit about what we do and who we are. To show you the extent of litter along our waterways in Ontario, we'll share some data. Then we'll take a tour of some of the upstream solutions that we work on and talk about how green infrastructure solutions are currently being applied in Ontario. And from this, you'll hear from several different researchers. We have 5 researchers here today that are going to tell you a little bit about the projects that they are currently working on. We'll also talk about what you can do at home and share some online resources. And as Emily mentioned, we have a costume contest going on, so please share some of your best on the water looks with us and tag us on Instagram or Twitter. If you submit your photos now or have already submitted them with us, we'll show some of our favorites at the end. At any point, you can chat any issues that you might be having with tech, and someone monitoring from our team can check it out. You can also ask questions when we get to our Q&A at the end by typing your questions into the chat box. So I hope you're ready. Grab your paddles and get ready to take a tour of Upstream Solutions with us as we talk about plastic pollution in our waterways. But first, before we dive in, we'll start with a quick game. See if you can spot the fish hidden somewhere in this image. I'll give you 30 seconds, and then I will reveal where the fish is hidden. I wish I had a Jeopardy song I could play here. Tick tock, 10 seconds. Were you able to find it? It's right here. I don't think this is a very realistic picture of a sea bottom floor because I don't think that there's any plastic except for maybe this chip over in the corner. I would be very surprised to see as little litter as there is in this picture. Okay, so let's get started. I'll start with a bit about the annual Day of Action on Litter, which is the day it is today. In October, during Waste Reduction Week, the Government of Ontario announced that it would recognize its very first Day of Action on Litter on May 12, 2020, a special day to promote environmental stewardship and bring cleanup activities to schools, neighborhoods, and municipalities across the province. Obviously, the original plans changed since this announcement in October, but we're still trying to celebrate and honor this day. This year, we hope to inspire action on litter and share some of and something that you can be part of from the comfort of your own home. It just so happens that this date also is around the time of our annual Clean Up the Don, in collaboration with Paddle the Don, hosted by the Toronto and Region Conservation Authority. The past 2 years, the U of T trash team has brought together hundreds of community volunteers to clean up litter along the Don River. And if any of you who are on this webinar today have volunteered with us in the past and the many cleanups that we've done, we thank you so much and we're looking forward to seeing you again next time. Although Clean Up the Don has been canceled, there are many opportunities to get involved and help take action on litter. And also on the bright side, we're looking at the silver lining of COVID-19. We're sad to not be out in the community doing our normal cleanups. We're thrilled about the broader audience a virtual event allows, and I'll still honor, paddle, and clean up the Don with my outdoorsy hat today. So now I'll move on and tell you a little bit about the University of Toronto Trash Team. We were founded in 2017 with a common goal to increase waste literacy in our community while also reducing plastic pollution in our ecosystems. Our team is made up of students, volunteers, early career researchers, and we're all dedicated to this important goal of reducing plastic pollution. Our main are around programs in schools, also community outreach and solutions-based research. And we're really going to highlight some of that solutions-based research with you today. What I love about the U of T trash team is the school programs that we've created. Students like me go into elementary and high school classes to teach about the effects of plastic pollution on fish and wildlife. And we also talk about how people can through their everyday lives. It's been really exciting to translate some of the research that we do in the lab and bring this to young people. Our school programs are currently aimed at grade 5 students, and these days we're moving these same lesson plans online, and many of them are available today. So you can check our website for more about school programs, and we're going to have Cassie putting in some of the links into the chat box so you can monitor that as we go. Community outreach, we lead several cleanups a year and we table events led by others. And you can always check our upcoming events page to see where we will be next. In response to the need for virtual outreach, we started a series of live recordings of children's books on the topic of plastic pollution. And we have many special guests, including the authors themselves. And we're joined by different members of our trash team every week to talk about what it's like to be a scientist. Our fourth event begins right after this webinar. So some of our members will actually jump off this webinar early. And our fifth and final event is Tuesday, May 19th, 2 p.m. So if you want to catch up, recordings are available on our website until the end of the school year at the end of June. And we also have other online activities and at-home challenges that we'll also talk about today, including some more fun and games. You can visit our website. We have coloring sheets and other activities and different ways to learn about plastic pollution. Next, we'll hear from Emily, who will set the stage and tell us a little bit more about pollution in Ontario and collecting data for the Great Canadian Shoreline Cleanup.
Emily, you're muted.
My apologies, I'll start over again. So every year we put together a Dirty Dozen list, and this is the 12 most commonly found items on our shorelines. The 2019 Canada-wide list has not yet been released, but we do have the Ontario Dirty Dozen list to share with you today. So a bit of a sneak peek. And unsurprisingly, we see that the most commonly found items by our volunteers in Ontario fall within the category of single-use plastics, many of which are not considered recyclable in many municipal recycling streams across the country. And this includes items such as cigarette butts, tiny plastics or foam, food wrappers, plastic bags, straws, and coffee cups. So for comparison, we have, sorry, next slide, please. Awesome, thank you. So for comparison, For comparison, we have here a list of the commonly found items on the Great Lakes, which includes the findings from municipalities adjacent to each lake. And most of the items on this list are the same as those found on the Ontario Dirty Dozen, the top two being cigarette butts and tiny pieces of plastic and foam, both which far exceed the total amount of other items on the list. It's important to keep in mind, though, that litter travels, and so litter that ends up in the Great Lakes could have traveled from areas farther away. Similarly, litter items that end up in the Great Lakes can travel to other regions via waves, wind, and even species. So regardless of where these items end up, we know that plastic negatively impacts various species along the Great Lakes as a result of things like ingestion, entanglement, or habitat destruction, for example. And this is shown here on the map, which represents the flow of water in each lake. You can kind of see those blue arrows. And the Great Lakes, St. Lawrence, Atlantic Ocean connection. The yellow dots represent cleanup site locations, and pictured are some of the species who are unfortunately negatively impacted as a result of plastic pollution. Unfortunately, if left in the environment, these single-use items that we find so often, including the plastic and cigarette butts, will continue to fragment over time until they become microplastics. And at this time, it's no longer feasible for our volunteers through the Great Canadian Shoreline Cleanup to remove them from the environment because they're too small to see. And although it's best to find alternatives to these single-use items and to ultimately keep them out of the environment in the first place, groups like the trash team are involved in solution-based research aimed at removing and preventing plastic pollution, including these hard to see and pick up items that we aren't able to tackle during a cleanup. So with that being said, I'm going to pass it back on to Lisa, who will go a little bit more in depth with the team about their solutions-based research.
Great, thanks, Emily. We know from data collected in shoreline cleanups, also audits of litter and research that looks at microplastics in the environment, that plastic pollution is an issue here on the Great Lakes as it is around the world. When we think about solutions, we lump into different categories, including waste reductions, as well as improved waste management and cleanups we really see as a bit of a last resort. These solutions are some of the things that we've tested in the lab on the screen, including Seabins, raingardens, litter traps, and washing machine. And our lab at U of T is interested in solutions-based research to understand how effective these different solutions are at removing plastic pollution from the environment. So now we'll take you on a tour of some of our solution-based research, and we'll work our way from downstream solutions, and we'll paddle upstream, and we'll end with you and what you can do at home. We'll start our journey in the lake and on the waterfront, and then what we'll do is we'll work our way upstream. There's many more solutions that we don't have time to present on today, like trash wheels on the waterfront or other trash capture devices. But there are many different solutions that can be placed throughout a watershed that captures plastic before it gets into the water. But keep in mind that throughout, plastic reduction is often possible too. So as I said, we'll start on the lake, and this is where Siebens work to filter out plastic pollution from water. We know that this is a really important action in Ontario since research has found microplastics in nearly every fish sampled across the Great Lakes. So now I'll pass it over to Tina and Cassie to talk a bit more about Siebens. Take it away.
Thanks, Lisa. Hi, everyone. I'm Cassie, and I've just finished my undergrad at U of T, and I'm now working with the U of T trash team. So one of the projects I'm involved in is the Sieben project with Ports Toronto. Siebens are an example of a plastic mitigation device, and they are otherwise known as floating trash collectors. They can remove any garbage or litter that ends up downstream of a water body, and the Toronto harbourfront is a great example for where lots of trash tends to collect. Siebens were originally created by 2 Australian surfers, and their idea became so successful that these devices are now cleaning bodies of water all across the world. The way that Sieben works is that it floats at the surface of the water, and it moves up and down with the range of the tide, and it collects any floating trash that is larger than 2 millimeters in size. And the water is sucked in by a pump within the Sieben that is on 24 hours a day. And inside the Sieben, just above the pump, there is a natural catch bag, which collects and holds any of the floating debris once it's sucked into the Sieben. Now this keeps the trash consolidated until someone can come and collect it, and it keeps it being further transported throughout the lake and harming any aquatic organisms. And a Sieben can collect up to 2 kilograms of trash a day, which makes it extremely effective. And now Tina is going to tell you a little bit about the Sieben pilot program, which she's conducted this past fall.
Hi, I'm Tina. I just finished my undergrad at the University of Toronto, and this fall, our team has been working, this past fall, our team has been working with Ports Toronto to investigate the amount and type of trash that ends up in the Seabins. So in phase 1 of the Sieben pilot program that started last summer, there were 2 bins that were placed in the outer harbour marina that were looked at and categorized. So on the top there, you can see Lara sorting through the debris. And under that picture, you can see me collecting some of the contents from those Siebens. And so in this phase 2 of the Sieben pilot program in Toronto's inner harbour included the additional deployment of 2 Siebens at Pier 6. And we collected the debris from each Sieben for 7 days. And every sample was sorted and quantified and we characterized the debris that was found. And they were separated according to size. Both audits were extremely successful, and phase 3 will be coming soon. We will be working with Ports Toronto based on the findings, and it'll help determine where the Siebens will be placed, and we will also continue to quantify and characterize the debris that's been caught at the new sites. So there are many different things that were found in the Siebens. From both phase 1 and 2, the most common items found were plastic fragments, films, and pellets, which also happen to all be microplastics. In comparison to phase 2, the most common types of larger item found were wrappers, fragments, and cigarette butts. These items may sound familiar as they were also mentioned in the Ontario Dirty Dozen. The total data collected, Siebens were found extremely diverse debris that they were able to catch. And through the second study, Pier 6 was also found to be a sink for many different types of debris, with the highest total of 27 different categorizations compared to the 13 found in the outer harbour marina. We have also shown through these preliminary studies that Siebens are highly effective in collecting various types of debris. showing promising efforts to help clean up the slips in Toronto's inner and outer marina. This type of research will help us with future investigations of plastic mitigation devices, as well help consider exploring and expanding of a broader network of Siebens in the Greater Lakes.
Next, we'll move upstream into the storm drains. And these are the ways that water goes off of roads and sidewalks and parking lots and eventually drain into tributaries and the lake. We know that stormwater is a major pathway for microplastics to get into the environment. And many of you likely have heard of wastewater treatments as a way that microplastics can get into the environment. But probably many of you don't know what a huge source stormwater runoff can be. Often stormwater runoff can be an even larger source of microplastics to the environment compared to wastewater treatment. From work in our lab, we found that stormwater runoff entering into Lake Ontario can contain over 29 anthropogenic particles per liter, and many of them are microplastics. So now I'll pass the mic over to Laura, who will discuss some stormwater runoff results, contaminants, including microplastics, and a study that she worked on looking at the effectiveness of rain gardens. Take it away, Laura.
Hey, thanks, Lisa. Hi, everyone. I'm Lara, and I've also just finished my undergrad at the University of Toronto. So for the past few years, I've been researching what sorts of litter we find in stormwater and to what extent rain gardens can filter out that litter. So what are rain gardens? Rain gardens, they're also known as bioretention cells, and they're really just specially constructed gardens that are designed to reduce flooding and improve water quality in urban areas. So they're located in places like parking lots, road medians, traffic circles, and they're designed to drain water from those surrounding paved areas. So two examples are actually on the slide here. In the Greater Toronto area at the Courtright Centre for Conservation, there's a rain garden in a parking lot. And then in this residential/commercial part of San Francisco, there's a boulevard rain garden. Next slide, please. So in natural environments, such as a forested green space area, surfaces are mainly pervious. That just means the rain drains through the soil. And then in urban settings, there are really large paved areas, so surfaces are mainly impervious, meaning the water can't really drain through the surface. And runoff water is created as a result of that. So rain gardens are a way to increase pervious spaces in urban areas and reduce stormwater runoff. Basically, the stormwater enters the rain garden and its soil filters out pollutants. So that can be like nitrogen, phosphorus, metals, and possibly microplastics. So yeah, recently our team investigated this. We studied the San Francisco rain garden that I mentioned before, specifically how effectively that rain garden filters out litter from stormwater, so microplastics, but also other anthropogenic particles. We went out during 3 different storms and measured the concentration of litter in stormwater before and after it passed through the rain garden. And the graph on the left just summarizes our findings of that. So the in bars in dark blue represents how much litter was in the stormwater before the rain garden, and the light blue bars where it says out, that's what was there afterwards. So the fact that the out bars are a lot lower, that indicates that rain gardens work really well. So that's great news. And in fact, doing the math, we found that rain gardens filtered out 96% of litter on average across the 3 storms. So in other words, 96% of litter was basically captured in the rain garden instead of entering storm drains, which eventually connect to larger bodies of water. The photos on the right, those are just some examples of what the rain garden is capturing. So we have rubber, which is like tire dust. Fibers, fragments, and foams are all types of microplastics. We also have glass beads and glitter. And just the last thing I'll mention, although this data is from San Francisco, rain gardens can really be effective anywhere. So it's definitely a potential solution we could explore here in Ontario too.
Much, Lara. We'll move on to our next solution where we're still stuck in the storm drains, but we're now moving off the road and into parking lots and plastic manufacturing sites. We know that around Toronto, many microplastics both in sediment and in surface water, appear to be industrial. You may have seen some of these industrial plastics, including pre-production plastic pellets, also called nurdles, which look like tiny uniform beads. And here to tell you more about these industrial plastics and how to prevent these from entering the environment, I'll pass it over to Nick, and hopefully you can hear him because it looks like he is underwater. Take it away, Nick.
Hey, so I'm Nick. Thanks for the introduction, Lisa. And recently I just finished my master's at U of T, and I've been working with the trash team on diverting microplastics that come from the plastics industry. So another type of a upstream solution to reduce plastic pollution are litter traps. And these litter traps are sturdy filters that are installed beneath the storm drain gate, and they're used to capture debris in stormwater. And these traps are installed with variable size mesh nets that can capture debris depending on the different size of the mesh openings. So how exactly does it work? So basically, around a storm drain, there's various types of debris, including plastic litter, leaves, and other organic material. And on a normal basis, when it rains, the precipitation will sweep all of this immobile debris into the storm drain, where it then directly enters the environment. But with this application, once the debris actually enters the storm drain, it will be captured by the litter trap, whereas the rain will actually flow from the bottom of the trap, the top or the midsections. At the very top of the trap, there's an overflow outlet, which is used in case debris and water fills up too quickly to avoid flooding. And then the trap needs to be manually emptied by simply opening the storm drain gate and then pulling out the installed mesh, sorting it, disposing it in the appropriate receptacle, and then returning the mesh back into its original place. So the litter trap itself works with many different types of debris. For example, a 5mm mesh net opening could work with common plastic litter that's found in the environment. And another application is with a finer mesh with approximately 1mm size openings, and it's used to capture pre-production pellets, which is seen on the leftmost image. And each pellet is approximately 2 to 4 millimeters in size, and these pellets are used as the building block of all plastic products. They're melted and molded to form the common plastic products we see as consumers. And at these facilities, pellets need to be transported from trucks, from rail, and from other cargo containers in the plastic manufacturing facilities. And this is where there's a high chance of pellets actually spilling. And since pellets are tiny and very large quantities are handled at once, they often are spilled and left scattered across the outdoor facility grounds. And if these aren't cleaned before it rains, then thousands of these pellets will be washed into the storm drains and directly enter the environment. So an example of a successful case study that used the litter traps for pre-production pellets is in New Zealand. So a company called Microplastics installed these litter traps in their storm drains and then collected these traps every 1.5 months. And the debris itself was collected into bags after. They weighed the debris, which contained pellets, rocks, and other organic material. They estimated the pellet weight relative to the total weight, and then calculated the final amount of these pellets at the end by weight. And it's also really important to note that this initiative was heavily managed by the employees at Medical Plastics, which shows that this trap can actually be a great way to get employees on board and demonstrate environmental stewardship across the entire facility. And according to their testimonial, it didn't take much effort or time to manage the traps, but they did manage to divert 220,000 pellets from entering the environment in just 1 year alone. So currently we're working on a project with the Canadian Plastics Industry Association to test these filters in local plastic production plant in Ontario and see how many of these pellets we can divert from escaping into the environment. And as an earlier initiative, we actually found up to 43 industrial microplastic particles per cubic meter of water in the environment just downstream from a cluster of plastic facilities. And we hope to use this initiative to reduce the amount of contamination that we see in the environment. And by building a strong case study locally, we hope to identify a viable solution for Ontario's plastic manufacturing facilities to divert plastic pellets from entering the environment.
Great. I really love the engagement of industry and then solution. And finally, our very last solution that we'll talk about today, we're moving upstream into your homes. This is some research that's very near and dear to my heart and something I'm working on for my PhD. And I think is a really important effort since microfibers are one of the most common types of microplastics in the Great Lakes. So here I'll pass it on to Dorsa, who is an undergrad who's been working with me on this for 2 years, and she'll tell you about this last solution presented in our session. Take it away, Dorsa.
Thank you, Lisa. Hey, everyone. As Lisa said, I'm an undergraduate student at the University of Toronto in the Rochman Lab. I have always been interested in the area of plastic pollution because I've grown up in a developing country where plastic waste is a major issue, and I'm so happy to have been a part of solution-based research. Sorry, am I muted or is it good?
You're good.
My research focuses on reducing our microfiber emissions into the environment. Microfibers are a type of microplastics that look like small fibers. Preliminary research results have suggested that microfibers can be as harmful to organisms as other types of microplastics. And in samples of fish from Great Lakes, our lab has found that the majority of microplastics in these fishes are actually microfibers. And that has inspired us to find a way to reduce our microfiber emission into the environment. A major known source of their production is through washing of clothing. Our lab has found that washing a red polyester blanket, such as the one on the left, can release up to 5,000 fibers per liter. Knowing that washing machines are a contributor to this pollution, we focused on capturing the fibers as they were leaving the washing machine. We tried 2 externally installed filters, such as Lint-Lovar and Filter 160, and we found that these filters were effective at capturing about 89% of the outgoing fibers. Next slide, please. The next step was to try one of those microfiber filters. We chose Filter 160 in the community level and people's homes. We chose Parry Sound in Northern Ontario as our site of study, and with the help of an environmental charity called Georgian Bay Forever, we installed 100 filters in houses that were connected to Parry Sound wastewater treatment plant, free of charge. Next slide, please. And the reason that they had to be connected to a wastewater treatment plant is because when the fibers leave the washing machine, they go to the treatment plant to be processed with the outgoing water. And the processed and clean water from the wastewater treatment plant is what's being released to the environment. So monitoring the number of fibers in the wastewater treatment plant is a logical step to see whether the filters actually worked. Luckily for us, there are only 1,000 households connected to this wastewater treatment plant. So enrolling 100 households in the project targets about 10% of the emissions and allows us to see any changes in the number of microfibers. We have only so far sampled one time after the filters were installed, and the downward trend in the number of microfibers has been very promising. We will return to the Parry Sound and wastewater treatment plant in summer 2020 to sample again, and we'll keep you updated. And on the far right, I have a picture of me in the wastewater treatment plant on a regular pre-pandemic day. Next slide, please. We also looked at the number of microfibers captured by the filters. Here on the right, I have a photo of what the fibers look like under the microscope. This picture has only about 5 milligrams of what is captured by the filter, so it's way smaller than a dime. But you can see that it's very densely packed. There's so many fibers in such a small area. And we found that and estimated that our filters captured 6 to 24 million microfibers in 1 year, and that's just one filter. If we are to employ that solution in Toronto, where there are hundreds and thousands and millions of households, we'll be capturing billions and trillions of microfibers per year. We also found that our laundry has a lot of other types of microplastics. On the left, I have a selection of types of microplastics that you can find in your laundry. We found glitters, of which I personally did not know were microplastics before starting this project, fragments, beads, paints, and so on and so forth. The bad news is that our laundry emits so many different types of microplastics. And the good news is that these filters are effective at capturing those and having them to be properly recycled or discarded instead of being directly reused into the environment. For more information on microfibers and our project in Parry Sound, you can tune into our evening seminar with Georgian Bay Forever, and the link is in the chat box. Thank you for listening.
Thanks, Dorsa. So we'll update the chat box in our question and answer period. And we'll just have a quick question and answers, and you can type in questions into the chat box and direct them towards any of our presenters. We've Cassie and Tina talking about Seabins. Lara talking about rain gardens, litter trap is Nick, and lastly, washing machine filters was presented by Dorsa. So we can monitor the chat box and field any questions you might have. I just wanted to first maybe get the ball rolling and ask Cassie and Tina a question. And wondering if you think you'd see differences in the type of debris that are collected in different Seabins. Are you seeing any differences now? And if you were to place more Seabins throughout Ontario, do you think you would see differences in the type of litter that you find?
So it's a great question. I guess Tina has been collecting more, but I suspect based on seasonal changes, especially around the marina, that we would definitely see differences in debris. And possibly it'd be possibly more difficult in the summer or the fall, depending on how much organic matter there is, which can help collect a lot more plastic.
Sorry.
Nope, you take over, Tina.
Oh, I think it might also depend on what activity might be nearby, because that would also have a heavy influence on what ends up in the area, eventually.
And Tina, in the downtown Toronto, you found lots of wrappers. You found do you think it's representative of what people are using downtown?
Yeah, so there's a lot of styrofoam and plastic fragments and wrappers and cigarette butts that were found, and like things such as water bottles. And I think it's not that surprising that they're found in the Sieben, as even when we do the shoreline cleanups or have a stroll along the lakeshore, we can already see those things on our sidewalks. And so it's not surprising that eventually it would end up in the water.
Mm-hmm. And Nick, so you've seen that litter traps work really well in New Zealand. Do you think industry in Ontario could be receptive to putting things like the litter trap in storm drains around?
Absolutely. Yeah, so absolutely. The pilot that we're currently working on right now is Ontario based, and I'm planning to direct the audience to the link in terms of how much a litter trap would cost as well, because I did see the question in terms of how much does a trap cost. So the litter traps are actually designed to fit into the Ontario-based storm drains as well as the New Zealand ones, and they can always make adjustments based on the sizing of the storm drain. So on top of that, is that Ontario is a hotspot for plastic manufacturing. So I do believe that there's a high possibility for these traps to really work well in Ontario.
Thanks, Nick. We have a question for Dorsa. Dorsa, have the residents with the new Filtrol filters in their washing machines experienced any problems maintaining or cleaning the filters? Was anyone resistant to having them in stock?
So far, they have all been really happy about it. Some some people wanted to volunteer, but they just didn't have enough space to install the filters. But our participants have been really happy about it. Our research is that for these filters, generally you would have to throw the lint in the garbage, but our participants had to freeze it. So that might have been a little difficult for them because it's for research purposes, but otherwise it's been going well.
I have a question we only have a few more minutes, but we'll see if we can get through these. So there's one question for Tina and Cassie. Are the Siebens used anywhere in Lake Erie? If so, could you please indicate where they are, if any conservation authorities or municipal governments are using them? So there are not Siebens anywhere in Lake Ontario. As I know, Sarah and Cassie, are there any plans to put any in Lake Erie that you know of?
Not that I know of, but maybe if you write in and suggest it would be a great idea.
Yeah, I think, if people can write in to their MP, or councillors, or town reeves. I know that there's one currently planned for Collingwood on Lake Huron in Georgian Bay, but none that I know of for Lake Erie, so it might be an interesting one to suggest. We have a question for Lara. And then I think this will have to be our last question. We can stick around at the end of the presentation and answer a few more. But Laura, how do you go about collecting the debris in the rain garden if the debris is deeply embedded? Do you want to maybe speak a little bit about how to process sediment in the lab, since you spent a lot of time working on this?
Yeah, I can talk about what we do in the lab. We use this technique called density separation. So we kind of like get the samples which have like a bunch of sediment and water, and then the litter as well that was captured. And then we put it with this solution that has a certain density that, kind of long story short, allows the kind of gunk to like settle to the bottom and the plastics to float to the top with like the solution in the middle. And then you put it in this like special device kind of that allows you to kind of release the stuff at the bottom and just collect the stuff that floated to the top, if that makes sense. So yeah, it basically just works off, I guess, the principle of like different densities, things floating versus sinking. And yeah, that's how we get the litter out in the lab, and then we look at it under a microscope and whatnot.
Great, thanks, Laura. So I see a few more sent me some questions. So at the end of the presentation, we'll stick around for a few extra minutes and answer any questions that you might have or share resources to get in touch with us. But we will move it along. Another thing that you can do at home, in addition to some of these solutions, which you could either put in your homes or advocate to have in your communities, is to take the 4-week challenge. And this is a 4-week waste reduction challenge. Since many people have been asking us and our team, what can we do to reduce waste while we're spending more time at home? And these 4 weeks are online, so you can start any day you like. And I will now pass it over to Rafaela, who is one of the founding members of the U of T trash team, and will tell you a little bit more about this effort. So take it away, Rafa.
Thank you, Lisa. Can you hear me?
Great.
Okay. So, hi everyone. I'm Rafaela, founder of U of T Trash Team, and we are very excited to be here with you today to present the 4-week waste challenge, a fun adventure to help thinking of what can we do to reduce waste during this interesting time. Next, please. Every week has 5 different challenges to complete, and we will focus on refuse, reduce, and reuse waste. Next, please. Here you can see the complete 4 weeks challenge. In this challenge, you will be challenged to do all kinds of activities, include waste audit, plant, crafts, cooking, take pictures, as well as many other fun activities. And to illustrate how it works, I would like to highlight a few activities on week 1 and week 4. So on week 1, you will start with a waste audit, bake a snack instead of buying snacks in packaging, and will be challenged to reuse and repurpose the materials that would become waste. Next one, please. And week 4, you will learn how to make your own cleaning product, how to use less plastic in your indoor gardening, and you will be challenged to rethink your single-use plastic in your bathroom. Next, please. So here we have some great examples of participants who are sharing their challenge with us. Cooking, waste audit, art, repurposing items, and other fun things. So thank you for those who have shared with us their enthusiasm. And thank you for you to being up for the challenge. We can't wait to see what you'll come up with. You can access the 4-week challenge, all complete 4-week challenge on our website, which is listed in our chat box and in the slides as well. So thank you for being up for the challenge. We can't wait to see what you come up with. Now let's get back to Lisa to wrap up.
Thank you, Rafa. Now we wanted to just thank you for joining us and learning about the things that we can all do to prevent plastic pollution and other litter from getting into our local waterways that we know and love. Before we part, we wanted to share some of the winners of our costume contest. We have winners to present, and then we will wrap up. So drum roll, please. Our winners of our costume contest are Best Paddling Trio, containing 2 paddlers and a tiny paddler on the right, and the Best On the Water look, our fearless leader, Chelsea, swimming in her living room. So thank you all so much for submitting your photos, and please continue to send pictures of you on the water, whether it's a paddling trip that you took last year or just you being silly in your living room. We would love to see your water looks, so continue to share them with us. We'll repost them, and we just love getting to see other people and feeling connected even though we are far apart this year. So now I'll pass it over to Emily just to say a few closing remarks.
Thanks, Lisa, and congratulations to the winners. So again, thank you guys all so much for joining us today. And a big happy Ontario Day of Action on Litter. And we're really looking forward to celebrating with you again, hopefully in October for Waste Reduction Week, as long as it's safe to do so. And I wanted to quickly chat about the next webinar that we have in our webinar series. It will take place on Thursday, May 21st, so next week at 1 p.m. Eastern Time, so same time as today. And we'll be joined by a Quebec-based group called De Ville en Forêt to learn about the 7 principles of Leave No Trace and how to reduce our impact on the environment. The webinar will be in French, but we will also be offering an online how-to guide to help you follow the 7 key principles of Leave No Trace. So stay tuned for that. And then as well, if you're interested in learning more about the impacts of plastic debris on ocean and freshwater ecosystems, please check out these great resources that are offered for free online by the U of T trash team, the Great Canadian Shoreline Cleanup, OceanWise, as well as WWF Canada. And finally, thank you guys again so much for joining, and please feel free to reach out to either myself or the trash team for more information or to answer any questions that we might not have had time to get to today.
Thanks. So we'll stick around for about 10 minutes until 2 p.m. We have some other questions in the chat box, so please feel free to write a message and we'll start to answer some of the questions. So some of you need to get off. Thank you so much for joining us, but we'll stick around just a little bit longer and we can dive in a bit deeper into some of the questions that many of you have posted. So I'm just scrolling up because some more questions came in before I got a chance to read it. I have a question for Nick. How often are the litter traps cleaned? And do you have any experiences of what it's like? Do you experience any complications with organic debris being mixed in with the filters? Is there a way to separate? Maybe the question is there a way to separate the plastic from other debris?
Thanks for the question. So I personally have never removed the trap, but I did watch a couple of videos of my colleagues removing the traps because I wasn't there at the site that day. How it works is that you lift the storm drain gate. It can be done by hand or with any sort of tool. And what happens next is that the trap should have handles installed and you just lift up the trap. Depending on the amount of organic debris, it could weigh quite heavy. So it might be a 2-person job instead of a 1-person job. And once you remove the trap, you just flip it over and empty all of the debris into a garbage bag or any sort for further sorting afterwards. In terms of the site that we have it at, it's at a facility, plastic manufacturing facility. So we don't get too much organic material there. So that hasn't been a problem. But one of the really awesome ways of sorting is to actually just dump it all into water because water makes the plastic float. So you can just scoop off all the plastic at the very top and then re-empty the organic material into another disposable.
Mm-hmm. Kind of like what Laura was talking about for doing the density separations with sediment. Nick, another question for you. It's about litter traps implementation in industrial facilities. Do you see something like this becoming a mandatory upgrade university-wide on the level of policy? It's sometimes hard to say. I'll pass it over to Nick, but before I do, I'll just say that for the washing machine filters, that there's already legislation requiring washing machine filters on machines in France, and all machines need to have a filter by 2025. So sometimes policy requiring these sorts of filters and traps could be possible. What do you think, Nick, in terms of industry-wide for lititrap and policy?
In an environmental perspective, that would be amazing because we'd be diverting the most amount of pellets from actually entering the environment, because quite a few of it goes through the storm drains and into the environment. From a difficulty standpoint, it will be challenging, simply because the traps have yet to be tested on a wide scale, especially on a governmental basis. So we believe that the research that we're currently doing at the U of T trash team, as well as the Rochman Lab, will be really important in terms of pushing this forward. Ideally, from an environmental standpoint, we would love to see it implemented at a wide scale basis, because the traps aren't expensive either, and it has a very high diversion rate, as well as it definitely brings in a lot of engagement standpoint, where the employees can actually be able to remove the sediment from the traps, and you guys can basically see the impact very, very easily.
Thanks, Nick. We have another question. This is for Laura about rain gardens. The question is, I wonder how you collected the water outflow before the storm.
Yeah, so that's a great question. Thank you for asking that. I didn't actually do the collection myself, so I don't have like all the details, but I believe for this rain garden specifically, there's like an under drain, so kind of like beneath the garden, and like in the lowest layer of the garden, there's just a little drain that kind of collects the water and then discharges that to a storm drain. So I'm pretty sure it was like during the storm itself, actually, they like collected the water just kind of at the base of that drain where it comes out. So yeah, that is the best answer that I have. Yeah, thank you again.
Thanks, Laura. So I'm just scanning the chat. I don't see any more questions. I think we've managed to answer. If not, for some reason I missed something and scrolling through the chat box, please don't hesitate to reach out. If you have any questions for any members of the U of T trash team, sorry, I think I see another one. Tina, did you want to answer a question?
I think there's a question about what you do with the collected litter, and I think that might depend on the project. So for some of the projects that are still happening, they keep the litter temporarily to analyze them further, and for other projects, we'll properly dispose of it after we're done.
Great, thanks, Tina. So if you have any more further questions or just wanted to get in touch, you can email Susan or Emily, and they will help direct questions to all of us. So with that, I just wanted to say thank you so much for joining us and being a part of our celebration for the first annual Day of Action on Litter. And we're really looking forward to seeing many of you again when things open back up. So have a great day, everyone, and thanks from all of us.